Hello, I'm Roy Ruddle, and this video shows you the third step of the 6-step data quality method. I've been working in data quality for more than 10 years, and we developed the method with input from data scientists and analysts working in more than 15 industry domains. The method is freely available, and you can download it from this GitHub link. We've designed the 6-step method to let you investigate the quality of your data efficiently, rigorously, and reproducibly. The benefits include, first, enabling you to do more in less time because the method tells you what to do. Second, reducing costs because we have grouped data quality checks into a carefully thought out order. Third, letting you get better results because by following our method you will understand the limitations of your data, correct misheld assumptions, and be able to clean your data as you progress through the 6 steps. We've created 7 videos, an overview, as well as a different video for each step. Now, step 2 showed you how to check for special values, such as data that's missing or invalid. Once we have done that, we can properly check for missing data, which is the purpose of this step. I'm going to show you how to investigate missing values in 3 types of data. For tabular data, I'm using a dataset about potholes in roads. And we'll look at 2 tasks, finding missing values and finding combinations of values that are missing together. For longitudinal data, I'm using the meter readings dataset that you encountered in step 2. And for spatial data, I'm using the traffic collisions data, which again you encountered in step 2. The examples in the videos use Python, the Viz Data Quality package, Jupyter Notebooks, and for the spatial coverage example, Tabular. So here is the Jupyter Notebook, and I'm going to start with the tabular data about potholes in roads. One of the most basic checks that you can do is just to calculate the number of missing values in each of the columns. Then we can create a visualization because that's quite a good way of seeing general patterns. Here we can see a bar chart. We've deliberately sized it so that the y-axis is the same as the number of rows in the data. So we can see the proportion of each variable that's missing, as well as the number of values that are missing. And what jumps out immediately is there appear to be 3 variables, completed, easting, and northing, that have missing values. Although if we look carefully, it appears that there might be a few missing values for the ward. Now let's create another bar chart, this time using Viz Data Quality. This time, straight away, we see that it's not just 3 or maybe 4 variables that are missing, but actually 7. We've got the 3 we saw first, completed, easting, and northing. Ward that was barely showing, but we see also that the reference, the road, and the cost are also missing at times. The reason why those are now being shown in this Viz Data Quality bar chart is because that uses something known as perceptual discontinuity to ensure that even very short bars are visible. When we look at this bar chart, and we've added labels, so we've got the number of missing values as well, we see that easting and northing, the coordinates of a pothole, are missing the same number of times. What we can also do with Viz Data Quality is visualize the different combinations of variables that are missing together. And we're doing this in the form of a heat map. So looking at easting and northing, first of all, we can see that though they appear in different combinations, they are always missing together. So our assumption that if one was missing, the other was missing is in fact correct. Although the most common combination is actually when just the completed variable is missing. Other things that we can tell are, for example, that if the road is missing, then the ward is also missing, but the converse is not always true. So that's tabular data. Let's go on to longitudinal data. For this longitudinal example, I'm using the water meter readings dataset again. And if you've looked at the step 2 video, you'll already know that as well as quite a lot of missing values, there were some suspicious zero values, which we're treating here as being missing. If I create a bar chart showing the number of missing values in each column, and again the y-axis is sized to be the same as the number of records in the dataset, I see that property reference and postal district are complete, but all of the year-month columns are missing, roughly speaking, about half of their values. I can look at the data another way as well, which is to ask how complete are the different rows of data. And so here we see that of the roughly 1,500 rows, most commonly are the rows, the roughly 120 rows, which are complete. But that only makes up about 8% of the data. The next most common pattern are the 80 rows that only have 3 months of data. So a question to be asked at this point would be, what's the aim of my analysis? Do I have enough data, or do I need to obtain some more data? To show you a way of investigating spatial coverage, I'm using the road safety data about traffic collisions. For each of the collisions, there are coordinates, a latitude and longitude. So one simple way of checking for spatial coverage is to plot those on a map. If we look at this map, we can see that there's no data at all for the majority of Wales here. You might notice there seem to be gaps up here, but bear in mind that in northern Scotland there are many mountains and hence no roads. But this hole in the data does seem suspicious. If I zoom in on that, then what we see is we're missing the data for the whole of an entire county, the county of Northamptonshire. So let's summarize step 3. We use pothole data as an example of tabular datasets, and we noted a number of issues in the data. We could potentially improve the data by adding the coordinates for the 272 potholes where the repair is being completed, but there was no easting or northing. For meter readings, we use longitudinal data, and the main finding there was that for very few of the properties is the data complete over the whole time period. So if I was analyzing that data, I'd need to ask, is this data sufficient for the analysis I want to do, or do I need a different data set? Finding that out at this stage would avoid rework later on. For the spatial data, we use traffic collisions. We found that the data for Wales is almost entirely missing, and we also found that data for a whole county in England is missing. It may be that you can obtain that missing data. It may be that the data you have is sufficient for the particular analysis or modeling that you want to perform, or you might have to go and seek additional data. Once again, if you'd like to download the method, you can do so freely from this GitHub link. If you have any questions, then do feel free to contact me. Thank you.